Hello everyone. So in our daily life you have seen many changes. So if you look at into this picture, in the first picture what you can observe? You can observe that a chain which is made up of metal, it undergoes a chemical change, that is rusting. And when it comes to the second picture, here a freshly cut apple, it changes its color after it is exposed to air for some time, right? And then when you look at the third picture, now I have a simple question. Can you identify the name of this statue? Yes, it is the Statue of Liberty. See, here in 1886, this is the color of Statue of Liberty, but at 2018, look at its color. That means the color of this Statue of Liberty is changed. That means we can say that in our daily life we can observe many changes. Either they may be changing the color, or they may be changing the state of matter, or there is a change in the shape, right? So here in this video you are going to learn an important topic of 9th standard ICSE chemistry, that is chemical changes and reactions. In this chapter, as the part 1, I am going to discuss chemical change, chemical reaction, conditions when a chemical reaction occurs, then characteristics of chemical reaction. So in this video we are going to discuss all these topics, that is chemical change, chemical reaction, conditions, characteristics of chemical reaction, as the part 1 of this chapter. So let us begin with this. Please watch this video till the end to get the information regarding all these topics. Okay, so what is meant by a chemical change? A chemical change is the permanent change in which the chemical composition of a substance is changed and one or more new substances with different chemical compositions and different properties are formed. If we recall the previous year classes, you have heard chemical change as well as physical change. So just recall the definition of these two terms. Physical change involves the change where no new substances are formed, whereas chemical change involves, it is the change where new substances are formed, that is with new chemical composition. So shall we take an example? Yes, if we take water as an example. So what is the molecular formula of water? So molecular formula of water is H2O, right? When we take this water in the form of ice, I will write here. What is the physical state of this water? It is in the form of solid. Okay, so in the solid state, what is the molecular formula? So molecular formula of water is still, it is H2O. Then on heating this ice, it will undergo melting process and it becomes liquid. Now what is the physical state of this water? It is in the liquid state, right? Now we call it as just water. Now whenever you heat this liquid, what happens? The liquid water, it turns to water vapor. See, now in all these states, either when the water is in solid state, or whether it is in the liquid state, or whether it is in the vapor state, still the molecular formula of water remains H2O, right? But if we pass electricity, if we pass electricity to the water, you know what happens? The water splits into its constituents. That is, I will write the simple equation here. Water, when you pass the electricity to this water, it split into its constituents, that is hydrogen and oxygen. Clear? See here, this is the molecule of water which contains hydrogen and oxygen, which is bonded together. But what are the products? It is the hydrogen plus oxygen. That means new substances are formed. That means from this example we can say the first example, it shows the physical change. That is, even though the solid turns into liquid, liquid turns into vapor, there is no change in the molecular formula. That means the chemical composition is not changed. So this is an example for physical change. Whereas when we pass the electricity to the water, it splits into its constituents, that is hydrogen and oxygen. That means new substances with new properties are formed. So these are the example for chemical change. Okay, so then if you look at into the definition again, what is a chemical change? A chemical change is the permanent change in which the chemical composition of a substance is changed and one or more new substances with different chemical compositions and different properties are formed. Please remember the example which I wrote here for the chemical change, that is water. When we pass current, it splits into hydrogen and oxygen, right? So here the change is not easily reversible. That means once the chemical change occurs and once the new substances with properties are formed, reversing that reaction is not easy, right? So for that reason we are saying it is not easily reversible. And then a chemical change always involves a chemical reaction. Then what is the chemical reaction? We have learned chemical change, that means new substances with new properties are formed, but here they are saying it is a chemical reaction. So all these chemical changes happens because of chemical reaction. Then what is a chemical reaction? A chemical reaction is the process of breaking the chemical bonds of the reacting substances, which we call it as reactants, and making new bonds to form new substances. That is, the new substances are formed. We call it as products. We will take the same previous example to understand this definition. That is 2H2O. It breaks into its constituent, that is 2H2, hydrogen and oxygen. See here. So if I write the simple structure of water molecule, so one oxygen, it is combined with two hydrogen atoms. Okay, one oxygen atom is combined with two hydrogen atoms. So such a molecule, how many are present here? Two molecules, right? So whenever it is forming the hydrogen, for example, if I write the hydrogen structure, I will write here hydrogen with a single bond, it combines with another hydrogen. Again oxygen, it combines with another oxygen with a double bond. See now, here oxygen is binded with hydrogen, but here hydrogen are combined each other, here oxygen are combined each other. So how does it take place? That is, it takes place by the breaking of the bonds in the reactant. I will repeat again, it takes place by the breaking of the chemical bonds in the reactants and formation of the new bonds to make new substances with new properties. So these kind of reactions or these kind of changes, we call them as chemical reaction. Shall we recall the definition again? A chemical reaction is the process of breaking the chemical bonds of the reacting substances, that is called reactants, and making new bonds to form new substances. We call it as products. So here how does it happen? It happens by the breaking of the bonds in the reactants and rearranging of these bonds to form new substances. Clear? We call it as a chemical reaction. Then we said it happens by the breaking of chemical bond. Then what do you mean by a chemical bond? If you look at the bottom of the slide, you will get the definition, that is a chemical bond. It is the force that holds the atoms of a molecule together as in a compound. For example, just now we wrote here, that is hydrogen H2 molecule, because hydrogen is an diatomic molecule. It contains two atoms and these two atoms are bound each other by the force of attraction. We call it as chemical bond. So how many bonds are present between hydrogen? Single bond. Okay, so this is called as a chemical bond. A chemical bond is the force of attraction that holds the atoms of molecule together. Now we know that what is the difference between physical change, a chemical change with an example, and a chemical reaction, and how does it take place, along with what is the meaning of chemical bond. Then what are the conditions for a chemical reaction to occur, or when does the chemical reaction occur? So just simply it will not take place, right? So there should be some conditions for the reaction to occur. So when does it happen? A chemical change or a chemical reaction occurs when particles collide. When it takes place, when the particles collide. So what do you mean by collide? So collide means when they hits each other. When the particles of the reactant hits each other, we call it as collision, right? Collision meaning just it is a hitting, or we call it as bombarding. Okay, so collisions occur when reactants are in close contact or when energy is supplied. So without contact we cannot say collision, right? For example, if you and your friend met with a accident suddenly, we call it as a collision. Why? Because when you met with this an accident with each other, your body touches with your friend body, so we call it as a collision. So this one or more of the following conditions are necessary for a chemical change. So what are those conditions? Either mixing, solution, heat, light, electricity, pressure, catalyst. So any one of these conditions are necessary for a chemical reaction to take place. So now let us discuss these points one by one in brief. The first condition is mixing. So in some cases a chemical reaction occurs when two substances are mixed in the solid state. So can you give an example? Already it is on the screen. Lead nitrate. What is the color of this lead nitrate? White. And potassium iodide. Again, what is the color of this potassium iodide? It is white. So when we mix these two, that is, they react to make lead iodide, which is in yellow color. This is the lead iodide. So lead nitrate, when it mixes with the potassium iodide, these two react with each other to form potassium nitrate and lead iodide. And what is the color of this lead iodide? It is yellow in color. See, when they are mixed in their solid state, these two are in solid state. When they mix each other, this reaction takes place. So new substances with new chemical composition or form. This is the first condition for chemical reaction to takes place. Then what is the second condition? Do you recall it? That is solution. So first of all, we will recall what do you mean by a solution. How is a solution is formed? So we commonly know that solution is the composition which is made by solute and solvent. Together it gives you a solution, okay, which will become the solute, a salt, or any substance which can be dissolved in the solvent. We call it as a solute. And what is the solvent? Solvent are the substance which dissolves solute. It is called as solvent. So when these two are mixed each other, we will obtain a solution. So for the chemical reaction to take place, they need or they should be present in the form of solution. So in some cases, not in every cases, here we are saying in some cases a chemical reaction occurs when substances are mixed in their either molten or aqueous state. Okay, so now we will know the meaning of this molten. What do you mean by molten? Just it is the fused form. It is the fused form of any substance. For example, say if you have sodium chloride. What is sodium chloride? It is a common salt, or we call it as table salt. When you heat it, the solid sodium chloride, it melts. Clear? It melts to give you the substance which is in the liquid state. We call it as molten state. So whenever on heating, if the substance is melted, then the liquid state of this substance we call it as molten state. Then what do you mean by an aqueous state? So here the name itself indicates aqua. So what do you mean by aqua? Aqua meaning water. That means the solution which is prepared by using water. For example, we will take the same sodium chloride. Just dissolve the sodium chloride in water. So on dissolving the sodium chloride in water, you will get solution, that is sodium chloride solution. Clear? So molten meaning it is the change in state, that is from solid to liquid state on heating. Then what do you mean by aqueous state? It is the state where the salt is mixed or dissolved in the solvent. We call it as solution. Okay. So now in the molten state or in the solution state, reaction occurs. For example, sodium chloride and silver nitrate react in a solution state. That means we took them as solution state. So when they are in solution state, we write it as aqueous. You know why we write it as aqueous? Because we have dissolved these salts in water. For that reason, we are saying sodium chloride is in aqueous state, silver nitrate in aqueous state. So on mixing these two, what we will get? It forms silver chloride, which is in white color. It forms silver chloride and sodium nitrate. See here in this reaction, these two reactants are in the solution state. Does the reaction occur? Yes, the reaction is taking place because it is forming new substance with new composition. Okay, then what is the third condition? The third condition is heat. So some chemical reactions occur only on heating. So we have seen many examples for this in our daily life also. For example, lead nitrate, that is PbNO3 twice, decomposes. What do you mean by decompose? Decompose meaning split. When on heating, leaving a yellow residue of lead monoxide, brown gas, that is nitrogen dioxide here, and a colorless gas, that is oxygen. So this lead nitrate on heating. So look at here, above the arrow we have indicated by a triangle symbol. So this symbol indicates heating. The reactants are heating. So on heating, it produces lead oxide, nitrogen dioxide, which is a brown gas, and a colorless gas, that is oxygen. So now I will tell you one thing. It is an extra information at this stage. We said this oxygen is a colorless gas. So how do we test the colorless gas oxygen and how we will confirm it? That is, when we bring a burning splinter near this oxygen gas, the splinter, it glows brightly. Clear? The splinter glows brightly. So that indicates the release of the oxygen during this chemical reaction. So please recall it because you need this for your practical exams. Then the next condition is light. So some reactions takes place in the presence of light. So some chemical reactions take place by the action of light. So these are called photochemical reactions or photolysis. Just if you know the meaning here, photo itself indicates light. What do you mean by photo? Photo, the term photo, it means light. For example, if you say photosynthesis, clear? I will repeat the word photosynthesis. Now, can you say what do you mean by photo? So photo meaning light. Here synthesis meaning food is prepared in the plant. So for the production of food, plant uses the light as the energy source. So that's why we call that as photosynthesis. Okay, and if you use the term photography, have you heard it? So photography, again, photo meaning light, graphy meaning a picture. So taking the picture with the help of light. So for that reason we are saying it as photography. Okay, but here we have two names, that is photochemical reactions or photolysis, and here we will recall the term also again. Photo meaning light, lysis meaning breakdown. So we will look at into this with an example. So now molecules of the reactant absorb light energy to get activated and then react rapidly. For example, plants, just we have discussed in the photosynthesis, plants form glucose, that is C6H12O6, from carbon dioxide and water in the presence of what? Light. Okay, so this light is absorbed by the chlorophyll. So for this reaction, it needs the presence of light to takes place. Okay, so this is an example for photochemical reaction. Then if you look at into the second term, that is photolysis. What do you mean by photolysis? Photo meaning light, lysis meaning breakdown. That means reactants has to break down or decomposition reaction may take place. So for that we have an example. Solutions of silver nitrate, that is AgNO3, decompose in the presence of light to silver. In the presence of light into silver and nitrogen dioxide and then oxygen. So see here, this reaction takes place in the presence of light. So in the absence of light, this reaction will not take place. Okay, and an important note here is, since the silver nitrate, or we can take silver bromides or hydrogen peroxide, all these undergo decomposition when they are exposed to light. For that reason, these kind of substances which undergoes photolysis, they are stored in brown bottles. In which bottle we will store it? We will store all this thing in the brown bottles. You know why? Because the intensity of the light reduces when you keep them in brown bottle. Please keep this in your mind. Okay, then what is the next condition? The next condition is electricity. So we know electricity meaning it is a flow of charges. You have studied it in your physics classes. Then certain chemical reactions like the decomposition of certain compounds occur only when electricity is passed through the reactants. For example, maybe you have seen rolled gold, or commonly we will say in our regional language Uma gold, right? That means gold plating, or the wheels of the vehicles, they are made by the method using electroplating method. So how does it happens? That is because of the electricity. That means these reactions takes place in the presence of electricity. For example, electrolysis of acidulated water occurs in the presence of electricity to give hydrogen and oxygen. Now just I will tell you the meaning of acidulated water. What do you mean by acidulated water? So here we are mentioning only H2O, but whenever we take this water as a reactant, to this we will add few drops of acid. You know why? Because whenever you add acid to this water, it increases the ionic conduction during electrolysis. That means it helps in the formation of ions. So when the ions are more, the current it flows easily when during ionic conduction of the electric current. Clear? So for that reason, as a reactant, we are taking acidulated water, and then on passing current through that, we will obtain hydrogen and oxygen. Okay, and easily we can collect these two gases in the test tube, and also we can test it. You know how? If you brought a burning splinter near this hydrogen gas, this gas burns with a pop sound. Clear? This is the confirmatory test for hydrogen. When you bring a burning splinter, near the hydrogen, it burns with a pop sound. And how we test the presence of oxygen? Again, same method. Bring a burning splinter near the oxygen or the test tube which contains oxygen, then the burning splinter, it glows brightly. So this is the confirmatory test for the production or release of the hydrogen and oxygen during this electrolysis reaction. Okay, now we will move to the next condition, that is pressure. So I think in physics you have heard the meaning of pressure. What do you mean by pressure? That is, it is the force applied per unit area. So you call it as pressure. So is it necessary for a reaction to take place? Yes, it is necessary for some chemical reactions. Some chemical reactions take place only when the involved substances are subjected to high pressure. Example, nitrogen and hydrogen, when subjected to high pressure, they produce ammonia, especially in the presence of iron as catalyst. I will repeat the example. Nitrogen and hydrogen, when they are subjected to high pressure, they produce ammonia. Look at here, we have the nitrogen and hydrogen, and it is an reversible reaction. So this is the indication of the reversible reaction, that is the arrow. At 200 atmospheric pressure, it produces ammonia. Okay, then what is the confirmatory test for this ammonia production? You know, because we have to conduct these experiments in your practical lab. If you brought hydrogen chloride gas near the ammonia, you know what happens when this ammonia reacts with the hydrogen chloride or hydrochloric acid. For example, if you take that glass rod, so dip the glass rod in concentrated hydrochloric acid, that is HCl, and when you bring this glass rod which contains concentrated hydrochloric acid near this ammonia gas, it produces a white smoke. That means in a solid form, that is, it forms the ammonium chloride. So that is the indication, or it confirms that the produced gas is ammonia. Okay, when it takes place during a pressure. Next one, catalyst. So what do you mean by catalyst? You know, there is a common example most of the teacher uses, that is, consider you want to run. So whenever you are running, sometimes even though you may put your effort, you cannot run with the fast rate. But imagine the situation when a dog is chasing you to bite, then what you will do? You know what happens? You will run with maximum speed as much as you can, right? That means here that dog, the chasing dog, what it is doing? The chasing dog, it acts as a catalyst on you. That means it is making you to run faster, right? So this is the meaning of an catalyst. That means some chemical reactions need a catalyst to accelerate, that means to increase the rate of reaction, or decelerate, that means to decrease the rate of reaction. So accelerate or decelerate the rate at which they occur. The catalysts themselves do not take part in the reaction and so remain unchanged. That means whenever you use any catalyst in a chemical reaction, as the end product you will get the same catalyst again. That means there is no change in the composition of the catalyst, so they remain as it is. So for this as an example, potassium chloride decomposes only at 700 degrees Celsius. Even then the rate of release of oxygen is very slow. But when we add this potassium chloride heated in the presence of manganese dioxide, that is MnO2, manganese dioxide, the decomposition begins at a much lower temperature and manganese dioxide remains unchanged. That is, then this reaction takes place around 300 degrees Celsius. See, there is a decrease in the temperature also, and there releases oxygen with fast rate. So when does it happen? It happens when we add a catalyst, that is manganese dioxide. And also after this reaction, the manganese dioxide, it remains unchanged. That means there is no change in the composition of manganese dioxide. So these kind of substances we call them as catalysts, which either accelerate or decelerate the chemical reaction. Then here, as a simple part, we have two types of catalyst. One is positive catalyst, that is which accelerates the rate of reaction, that means which increases the rate of reaction. For example, the rate of decomposition of hydrogen peroxide increases in the presence of manganese dioxide. So if we add again manganese dioxide to this reaction, what happens? This hydrogen peroxide decomposes into water and oxygen with high rate. But how we can control it? That is, if you want to store this hydrogen peroxide, it is a difficult task. Why? When it is exposed to the atmosphere, it breaks into water and oxygen. So whenever we want to store it, we will use negative catalyst. That means to prevent the breakdown of this hydrogen peroxide, we will use negative catalyst. So a negative catalyst employed to retard the rate of reaction is known as a negative catalyst or inhibitor. That means they will not allow the reactant to become product. For example, phosphoric acid, it retards the rate of decomposition of hydrogen peroxide. See, we took the same reactant, hydrogen peroxide. If we add manganese dioxide, it decomposes readily to produce water and oxygen. But when you put phosphoric acid to the reactant, it will not undergo decomposition reaction. Okay, so the next condition, so now we will move on to the next topic, that is characteristics of chemical reaction. Why we have to study this? Because whenever a chemical reaction takes place, how we will come to know the chemical reaction is happen? That is with the indication of some changes. So these changes we call them as characteristics of chemical reactions. Certain chemical reactions are characterized by changes that are quite easily observed. Some of these typical changes are: first one, evolution of gas; second, change of color; third, formation of precipitate; fourth, change of state. First feature is evolution of the gas. So in chemical reactions, one of the product is a gas. Sorry, here it is. One of the product is a gas. For example, see here, what we have a test tube. In the test tube, we put some zinc granules, and whenever we add dilute sulfuric acid, that is H2SO4, into this zinc granules, what you can observe here, we can observe bubbles, that is gas bubbles, which is evolved as the effervescence. So these bubbles contain the gas, that is hydrogen gas. And I think no need to say the conformity test again. How we will test the presence of hydrogen gas? That is by using burning splinter, which gives the pop sound. So this is an characteristic feature of a chemical reaction, that is evolution of gas. Not only this one, we can see many examples at your home also. Whenever you put some lemonade into the soda which is present in your kitchen, you will get effervescence of carbon dioxide, right? Again, this is the reaction where the gases evolved. Then second feature is change of color. So certain chemical reactions are characterized by changing the color of the reactants. For example, in this reaction, we took iron and copper sulfate as the reactants. So whenever we put some iron nails or iron pieces into the copper sulfate, see here, what is the color of copper sulfate? So copper sulfate color is blue. So when we dip this iron nail in the copper sulfate, after a few minutes or 15 minutes, say 15 minutes, we can observe change in the color of the copper sulfate. That is, from the blue color, it turns to light green. Okay, so can you observe the change? It changes from blue to green color. That means here we can observe change of color. For example, when a few pieces of iron are dropped into a blue colored copper sulfate solution, the blue color of the solution fades and eventually it turns light green due to the formation of ferrous sulfate. So what is the color of ferrous sulfate? It is green in color, and then this copper gets deposited on the iron nail. So you can see that in this picture. So this is an example for change of color, and keep this in your mind. I'm giving only simple examples, but whenever you study your textbook, you will get many examples for these kind of characteristic of chemical reaction. So now we will move to the next feature of the chemical reaction, that is formation of precipitate. First we will know what do you mean by precipitate. So precipitate is the insoluble substance which is formed during a chemical reaction. So certain chemical reactions are characterized by the formation of insoluble solid substances called precipitates. Example, when a solution of silver nitrate is added to a solution of sodium chloride, a white insoluble substance, that is precipitate of silver chloride. So here the white substance which is formed is silver chloride and sodium nitrate is formed. Just look at this picture. We have sodium chloride in aqueous state, silver nitrate in aqueous state. Whenever we add silver nitrate to the sodium chloride, a white precipitate is formed. What is the name of this white precipitate? It is it is the silver chloride which is formed as precipitate, and sodium nitrate, it remains as aqueous solution. Okay, so this is the one more example for formation of precipitate, and it is the third characteristic feature of a chemical reaction. Then another feature of the reaction is change of state. You know that there are three states of matter: solid, liquid and gas. Then in chemical reactions, a change of state is observed. A reaction might start with gaseous or liquid reactants and end up with solid products or vice versa. For example, see, in this picture we can observe that from one conical flask we are producing ammonia gas, and in the another conical flask we are producing hydrogen chloride gas. When these two gases are passed each other and when they combine together, they forms a white solid matter, that is ammonium chloride, which is in the form of solid. Okay, so ammonia state is gaseous state because we are passing it in the form of gas, and hydrogen chloride as in the state of gas. When these two gases combine together, they form a solid. That means change in state of matter. So example is ammonia gas reacts with hydrogen chloride gas to produce solid ammonium chloride. So ammonia is in gaseous state, HCl in gaseous state, and ammonium chloride is solid. So these are the example and characteristic feature of a chemical reaction. Do you recall it again? Which is the first feature, that is evolution of gas. Second feature is the change in color. Third feature is formation of the precipitate, and fourth feature is change of state. So this is regarding first part of the lesson, and in the next video we will learn types of chemical reaction and energy change in chemical reactions. So if you like this video, please press the like button and subscribe to this channel to get the further videos regarding chemistry classes and some basic sciences. Okay, thank you.